Hello and welcome back to Math with Mrs. Becker. This is College Algebra. We are looking at Chapter 1, Section 2, the second half of the section. We will start off today by looking at what is called a piecewise function. Now, a piecewise function, it is a function that has two or more equations or pieces, and each piece has its own specified domain. So right off the bat, let's check this out. This is a piecewise function. Notice it has two pieces. Now the top equation, you use this function if your domain, your x's, are smaller than 0. So if you are trying to solve or evaluate for any x value that is less than 0, you use the top function. Now the bottom, the domain is x is greater than or equal to 0. That means if the x value you are trying to evaluate for has a value of 0 or greater, you fill it into the bottom function. You will never fill a value into both. You have to figure out, based off of the domain value, do I fill it into the top equation or do I fill it into the bottom? So first off, let's go f of -1 because they want us to solve if our x value is -1. So your first step is to look and say, okay, is -1 less than 0 or is it more than 0? Well, it's less than 0. So I need to fill that -1 into the top equation. -1 squared. -1 times -1 is +1, plus 1 is 2. So f of -1 is 2. Now x equals 0. So that's f of 0. Now notice both domains share or show a 0. But what you have to do is figure out which one includes it. This is x is less than 0. This is x is greater than or equal to. So if x has a value that's equal to 0, we need to fill it into the second equation. So 0 minus 1 equals -1. Last but not least, let's go f of 4. So again, 4 is greater than 0, so we are using the bottom equation. 4 minus 1 is 3. You guys just evaluated piecewise functions. Let's do it again because it was so much fun. Okay, now this piecewise function has 1, 2, 3 pieces. Same idea. You will only use one of the expressions as you are evaluating. If your x value is smaller than 0, you put it into 5 minus 2x. If x is 0 or anything up to but not including 1, your value is automatically a 5. Notice this is a constant. Okay, so for any value that is 0 up into 1, the result will be the number 5. If you have an x value that is greater than or equal to 1, you'll plug it into 4x plus 1. So let's check this out. If I have f of -2, -2 is less than 0, so -2 fits into the domain of the top expression. Now we need to use order of operations. Remember, you multiply before you subtract. So this 5 is still there. The negative is tagged to the 2, so it's -2 times -2. That's a +4. 5 plus 4 is 9. F of 1/2. Now 1/2 is in between 0 and 1. For any values in between that 0 and 1 range, your result is simply the constant 5. If I have f of 1, okay, this shows a 1, but x is less than 1. If you have a value that is equal to 1, we need to use x is greater than or equal to 1. So I need to go ahead and fill that into 4 times 1 plus 1. 4 times 1 is 4. 4 plus 1 is 5. And last but not least, f of 0. A 0 is shown on the top and in the middle, but the one that includes it is in the middle. So f of 0, I use the middle expression, which gives us a result of 5. So the first two examples, we were doing what is called evaluating piecewise function. The main thing I need to stress is that you will not put a numerical value into more than one expression. You have to figure out based off of the domain which one expression do you use. Okay, let's move on. Using functions to solve for x. It says find the values, so we might have more than one answer, of x where f of x is equal 0. So what that means is we can go into this expression. They're telling us to change f of x to a 0. So 0 equals 5x plus 1. We have to find x. So I am simply just solving an equation. 0 minus 1 is negative 1 equals 5x. If I divide both sides by 5, x equals negative 1/5. So what this tells me is if I put negative 1/5 in for x, the whole thing is going to end up equaling a 0. Let's look at one more. F of x is 0 equals 2x minus 3 over 7. So if I want to solve for x, I need to first cancel the denominator. To cancel the denominator, you need to multiply both sides by 7. 7 times 0 is 0. That equals 2x minus 3. Now what I need to do is add the 3 over. So I'm going to move up over here. 0 plus 3 is 3 equals 2x. To solve for x, I need to divide both sides by 2. So x equals 3/2. So this is what you would do if they want you to find the values of the variable where the function is equal to 0. You replace f of x with 0 and then simply solve for x. Moving on. Now they want you to find the value or values of x where these two expressions are the same. So for me, this is fun, okay? We're going to take f of x and g of x and set them equal to one another. So x squared minus 2x plus 1 equals 7x minus 5. And right now I have a power of 2. So thinking back to Algebra 2, when we looked at Chapter 6, that fundamental theorem of algebra tells us that whatever the degree is, that's how many solutions we need. So I know I'm going to find more than one value, which is why that s is there. In order to do that, we need to first set it equal to 0. So I'm going to minus 7x. Remember to line up your like terms. Add 5 to each side. So what I have, I'm just going to go to a separate sheet of paper because I write big. I have x squared, negative 2x when I minus the 7x. Now I have a negative 9x. 1 plus 5 is 6 equals 0. So from here, I can factor, possibly. If not, we always have the good old quadratic formula. Are there two numbers that multiply to 6 and add to a negative 9? Well, if I think of ways to get 6, 1 times 6 is 6, and 2 times 3 is 6. I can't make either of those options add up to a negative 9. So I'm going to have to use the quadratic formula. A is 1, B is negative 9, C is 6. X equals negative B. The opposite of a negative 9 is a positive 9, plus or minus the square root. If I go b squared minus 4 times a times c, and again, let's just go ahead and calculate that. That's the number that goes underneath the radical. Negative 9 squared minus 4 times 1 times 6. I get 57. Okay, now 57, I can't break that down at all. 57 is 3 times 19, so there is no way to simplify that at all. All over 2a, 2 times 1 is 2. So here are my two solutions. 9 plus the square root of 57 all over 2, and 9 minus the square root of 57 all over 2. Those are the two values that if I fill them in for the x's, you would get the same value for both the f function and the g function. Okay, moving on to something that is called the domain. The domain, hopefully you remember that what they're talking about are your x values. The domain of a function is the set of all of the inputs. Remember, x is input. It's the independent variable. It is set A. It is the domain, okay? It's all of those different things. But the domain of a function is the set of all values or inputs of the independent variable that it is defined. So when we specifically look at domain, what we are looking for is where it's not defined. Those are the limitations. In math, you cannot divide by 0. If you divide by 0, it is not defined. You cannot have a negative underneath a radical, because when that happens, it is not defined. It's no longer real. You jump into the world of imagination. We have our imaginary numbers. Okay, let's look at the back. So what they want us to do is identify the domain. So you are looking at those two restrictions. Restriction number 1, you cannot divide by 0, okay? So that means whatever's on the bottom, x squared minus 4, that can never equal 0. If I solve for x squared cannot equal 4. If I take the square root of each side, anytime you cancel a power of 2, remember you need to include both positive and negative. Square root of 4 is 2. So this is the domain. This means that x can be any number except for a positive 2 or a negative 2. Because if I put a positive 2 in here, 2 squared is 4, 4 minus 4 is 0. If I put a negative 2 in here, negative 2 squared is 4, 4 minus 4 is 0. So these two values are called domain restrictions. And when they're asking for the domain, that's what they're looking for. What values do you have to exclude in order to keep this thing so it is defined? Okay, the next one, this is a quadratic. Remember, we do have two restrictions. I do not have a denominator. I do not have a radical. So neither of those two restrictions have anything to do with this function. So this function is defined for all real numbers. There are no restrictions because you do not have a fraction and you do not have a radical symbol, so your domain is all real numbers. C, I don't have a fraction, but I do have a radical. You cannot have a negative value underneath the radical. So that means whatever's underneath has to be greater than or equal to 0. So my domain, I can use any x's that are 0 or anything greater. Now this is a relation. Just trying to tie it back to the first part of this section. If they give you a relation and they say identify the domain, we're not really looking for limitations here. They just want to make sure that you remember that the domain represents the x values. So our x values in this relation are -3, -1, 0, 2, and 4. The domain would be the x values of that relation. Okay, now E. I do have a fraction. You can never divide by 0. So that means x plus 5 cannot equal a 0. So we do have a limitation. If I solve for x, x can never equal -5. Because if I put a -5 on the bottom, then I would be dividing by 0. It would be undefined. So this means that x can be any value, anything. It could be 1.2. It can be -0.888885. It can be anything except for a -5. Okay, now F, we have a square root, or in this case, it's a 6th root, but it's the same thing. This is an even root. If you have a negative value under here, it's imaginary. So whatever's underneath this symbol, 4 minus 3x, it cannot be negative. That means it has to be greater than or equal to 0. So at this point, I just need to solve for x. So if I minus 4 to each side, -3x is greater than or equal to -4. Divide both sides by -3. Negative cancels a negative, 3 cancels a 3, x is alone. If you divide both sides by a negative, remember to flip your sign around. Negative divided by a negative is a positive, so your x values have to equal or be less than 4/3. Okay, the next thing, can you figure out what the domain would be if they give you a graph? Now, here we do see that there are endpoints. This means that the graph does not carry on beyond this, what is shown here, okay? These are stopping and starting points. So my domain, the x's are in between 3 and 12. So the way that you would show the domain is your x's are in between and including the endpoints. So x is between 3 and 12. Domain, you're telling what the x values are. Now here there are not points at the ends. If you do not see points at the end of a graph, you are to assume that it continues in that direction. Okay, at this point they will, in most cases, stop writing the arrows. The way that you know that it continues is they will not put a stopping point. Okay, so again, if there's not a stopping point, assume that there's an arrow and it continues. So if I'm looking at the x values, this goes forever and ever and ever and ever this way. This goes forever and ever and ever this way. So your x values, everything is included, negative, 0, positives. So your domain is all real numbers. And that is the second part of 1.2. Thanks for tuning in. I'll talk to you later.